Now, how to generate random numbers from a linear model? Suppose we want to simulate from the following linear model: y equal to 0 plus 1x plus, where n of 0 to 22, assume x n of 0 to 12, 0 equal to o equal to 0 to 5, 1 equal to 2. So now we can proceed with setting dot seed of 20, and x as random normal of 10 100, and e as random normal of 100 comma 0 comma 2, and y equal to zero point 0.5 plus 2 into x plus e. This is the linear model that we are trying to create. So if you create, if you use summary of y, I've used the for e and x, I've used a random number of 100 and random number of 100 where the standard deviation is 2. So this is why how I've created the linear model. So now with the minimum value is 6.40. This value might change based on the random normal variates. Minus 6.4080, minus 1.5400 is the first quartile. Median is 0.686789, mean is 0.6893, and your third quartile is 2.9300. I mean, which is the second quartile is the mean, and maximum is 6.5050. Now if you plot x comma y, you will get a linear model with the function y equal to 0.5 plus 2 into x plus e. Now, what if x is a binary? So I can use a binomial distribution, like you can set the seed. I'm setting the seed here. You can name any number of integer in this, which basically sets the seed. So set dot seed of 10. Now I have a x, which is the random binomial variates 100, mean equal to 1, and standard deviation equal to 0.5. Now if I have E is the error or the noise, where the random normal variates is 100 comma 0 is the mean, 2 is the standard deviation. Now the function y is defined by the linear model y is defined by 0.5 plus 2x plus e. So the only difference between the previous one and here is that I've used a binomial variates here. So when I use summary of y, you will get the values. The minimum values, again, it might change based on the binomial variates and normal variates here. Minimum is 0.3 minus 0.3490. First quartile is minus 0.1409. Median is 1.5770. Mean is equal to 1.4320. Third quartile is 2.8400. Max is 6.9410. Now when you plot xy, you will get the linear model, but this x is a binary. So using the binomial distribution, we have plotted the linear model in the graph. So again, suppose if you want to stimulate from a Poisson model where y is a Poisson, so you want to generate a model where the model is followed by log equal to O0 plus 1x, and the O plus 1x, and O equal to 0 to 5, and 1 equal to 0 to 3. So we need to use the rpice function for this. So set dot seed of 1, so to remember the random number variates, and x is random number of 100, and log dot mu equal to 0.5 plus 0.3 star x. So log dot mu is the function where you have 0.5 plus 0.3 star x, and y equal to rpoise of 100 comma exp of log dot mu. And when you get summary of y, so minimum is 0.00, first quartile is 1.00, median is 1.00, again mean is 1.55, your third quartile is 2.00, and maximum is 6.00. So when you plot this, you will get up using the random numbers generated from Poisson distribution, you can create a linear model using this. These are some basic examples I'm trying to give you so that it might be useful to create those. So now we have seen about this distributions, and but what else can this random number generation be useful for? Let's say uh, you would have heard about the common examples where in especially in manufacturing industries they try to test the products. It is impossible to test products when you are manufacturing lakhs and lakhs of products. So you have to create sample a perfect sample from which the testing needs to be done. So here uh, R allows you to create random sampling methods. The sample function draws randomly from a species set of scalar objects, allowing you to sample from arbitrary distributions. So you have set.seed of 1, and I use sample of 1 to 10 comma 4, which means I need to create a sample of 4 from values 1 to 10. So it gives you a random sample from 1 to 10. Same way again, if I use again, it keeps changing. So, and sample of letters means the alphabetical English alphabets A to Z, and I'm creating a random sample of 5. And for same way, for example, sample of 1 to 10, here I'm trying to just create a permutation out of 1 to 10. So you'll get random, there's just a permutation here. Sample of 1 to 10, again there is one more permutation as given as an example. And sample of 1 to 10, if replace equal to true, so which means you are allowing the replacement. So not necessarily all these 10 will be unique. So for example, here 297 gets repeated again, 97, 8 repeats 3 times, 2 repeats 2 times, 8 repeats 2 3 times, etc., etc. So these are some examples of how to use sampling methods to create particular perfect samples. So to summarize simulation, like these are very much useful when you want to use large sets of data to simulate your model. So, drawing samples from specific probability distributions can be done with R star functions, which are R norm, R poise, R binom, etc., etc. So standard distributions are built in, for example, normal, Poisson, binomial, exponential, gamma, etc., etc. So the sample function can be used to draw random samples from arbitrary vectors. So setting the random number generator seed via set.seed is critical for reproducibility. So if you want to use any random set of Poisson variates or normal variates, you need to use set.seed to remember those values for in terms for next calculations or verifying your previous calculations. So with this we'll finish off simulation, and we'll continue with the rest of the class.